Here we're given the equation of a conic. We'd like to rotate the axes so that there's no xy term, and then we're going to discuss and graph the new equation. We're given the equation 41x squared minus 24xy plus 34y squared minus 25 equals 0. If we substitute x equals x prime cosine theta minus y prime sine theta, and y equals x prime sine theta plus y prime cosine theta, we will transform our equation into one that represents a rotation through an angle theta. To eliminate the x prime y prime term in the new equation, we need to have the cotangent of 2 theta equal to a minus c over b. That is, we need to solve the cotangent of 2 theta is equal to negative 7 over, that's 2 theta there. Cotangent of 2 theta equals negative 7 over 24. Since the cotangent of 2 theta is negative, we can choose theta to be between 2 theta is between 90 degrees and 180 degrees, which means that theta is between 45 degrees and 90 degrees. If we go ahead and look at triangle, we're going to imagine that this is the origin. We rotate through an angle theta, or 2 theta. Then we know that this is 24, this side is 7, there's our right triangle. And using Pythagorean theorem, we'll get that our hypotenuse is 25. We have that cotangent of 2 theta equals negative 7 over 24, so it follows that the cosine of 2 theta must equal negative 7 over 25. We want to find the sine of theta and the cosine of theta next. The sine of theta is equal to the square root of 1 minus cosine of 2 theta divided by 2. And that's going to equal 4/5. The cosine of theta is equal to the square root of 1 plus cosine 2 theta divided by 2, which is equal to 3/5. You can find out what theta is. Theta is equal to cosine inverse of 3/5, and that's going to be about 53.13 degrees. Now with these values, we can obtain our rotation formulas. We'll get now that x is equal to 3/5 x prime minus 4/5 y prime. Y is equal to 4/5 x prime plus 3/5 y prime. If we go ahead and substitute these expressions into our original equation, we'll get 41 times our new value for x, that's squared, minus 24 times our value for x times our value for y, plus 34 times our value for y squared, and that's going to equal 25. If we want to multiply both sides by 25, that will get rid of our denominators, and then we're going to expand each of these squares and this product. We'll end up with 41 times, in parentheses, 9x prime squared minus 24x prime y prime plus 16y prime squared. Then here we'll have minus 24 times, in parentheses, 12x prime squared minus 7x prime y prime minus 12y prime squared plus 34 times this in parentheses, 16x prime squared plus 24x prime y prime plus 9y prime squared, and then all of that's going to be equal to 625. If we actually multiply or distribute our 41, the negative 24, and the 34, distribute and then simplify by collecting like terms, see a lot of stuff will go away, and we're going to be left with 625x prime squared plus 1,250 y prime squared equals 625. So everything goes away except for these two terms. If we divide both sides by 625, we'll get x prime squared plus 2y prime squared equals 1. Then we'll go ahead and rewrite that in this form. So we'll have x prime squared divided by 1 plus y prime squared divided by 1/2 is equal to 1. We've just rewritten our equation. In this form, we can see that a is equal to the square root of 1, which is 1. B is equal to the square root of 1/2, which will give us the square root of 2 over 2. This is the equation of an ellipse with the center at 0, 0 in the x prime, y prime plane. The vertices are going to be -1, 0 and 1, 0, again in the x prime, y prime plane. You know that c squared is equal to a squared minus b squared, so that's going to be 1 minus 1/2, which is equal to 1/2. So we know that c is equal to the square root of 2 over 2. Therefore, our foci are going to be located at the points plus or minus the square root of 2 over 2, 0. Again, we're talking about the x prime, y prime plane. And we can summarize all the information that we've obtained at this point in a table. Here we have the center, vertices, minor axis intercepts, and the foci. We've got our x prime, y prime plane, and then the xy plane. So our center is at 0, 0 in both cases. You can see how the vertices are different, the intercepts are different, and the foci are different. We've rotated from the xy plane to the x prime, y prime plane. We're going to go ahead and use this information to sketch a graph now. Here we have our grids. We notice that the xy plane is in the background. It's lightly grayed so that we can show how we did our rotation. So that we got the x prime, y prime plane. Pay attention to the scale here. Each one of these tick marks represents 1/3 of a unit. We're going to plot our center first, and we're plotting in the x prime, y prime plane. The center is at the origin, 0, 0. The vertices are at plus or minus 1, 0. So we're going to go positive 1, that's over here. That's the point 1, 0. And then negative 1 is right here. So that's the point -1, 0. Again, we're looking at the x prime, y prime plane. The intercepts along the minor axis are going to be at 0 plus or minus roughly 0.7 because we have the square root of 2 over 2. So we're going to go down to about here and then up to about there. So those are the intercepts along our minor axis. That will give us 0, negative square root of 2 over 2 for that point. And then up here we'll have 0 and a positive square root of 2 over 2. We're going to plot our two foci. That's going to be at roughly plus or minus 0.7, 0. Again, square root of 2 over 2. So our foci are going to be about here and about there. We're going to go ahead and sketch the graph of our ellipse in the x prime, y prime plane. And so there's the graph of our ellipse.